Good afternoon, or good morning, depending on where you are. Welcome, everybody, to today's One Key Idea webinar, coming to you live from an undisclosed location. You can hear the audience in the background, perhaps, and they will be joining us for Q&A. I'm Rex Black. I'm president of RBCS. We are a training, consulting, and expert services company focused on software testing and quality. And in keeping with the spirit of the One Key Idea webinars, we're going to get right into it here. And we're going to talk about a technique that can be very useful to you for measuring the value of your testing called cost of quality. This is a very well-established technique that dates back to at least the 1950s. It's described by J.M. Duran in one of his books, The Quality Control Handbook. And it's a way of thinking about costs associated with building and operating, maintaining a product. In this case, we'd be talking about a software product. And it identifies four specific categories of costs that relate to quality. One is called cost of prevention. So cost of prevention is any cost that you incur that is about preventing defects from happening to begin with. For example, training your developers to write better code, more secure code, more maintainable code. That training is a cost of prevention. Okay? Cost of detection are costs that you incur as part of attempting to detect defects after they have already been introduced. Executing a test the first time is a cost of detection. Creating a test is a cost of detection. Setting up a test environment is a cost of detection. These are costs that you would incur whether you found any bugs or not. Okay? Costs of internal failure are costs that you incur because you find bugs prior to delivery of the product, in this case, the software. So if you find a bug, time you spend writing the bug report in Jira, that's a cost of internal failure. The time that you spend doing a confirmation test of a bug fix is a cost of internal failure. The time that the developer spends fixing the bug is a cost of internal failure. Okay. Then we have costs of external failure, and these are the costs that you incur when the software is delivered to customers and users, and they experience the effects of the bugs, the failures associated with the bugs, and there's their time associated with that. There's bad PR associated with that. There is time associated with fixing the bug and getting the bug fix into the production environment associated with that. Those are all costs of external failure. Okay, so those are the four categories of quality costs. And notice it's basically just about looking at a pile of money and breaking it down into four distinct groups based on, are we trying to prevent bugs? Are we trying to get ready to find bugs? Have we found bugs prior to release? Are we dealing with bugs after release? Those are pretty much the four piles. Now, testing, if you look at the testing bucket of money, the testing budget, that typically breaks down into cost of detection and cost of internal failure. Now, there might be some activities, some very limited activities that some testing groups would carry out that would be categorized as a cost of prevention. But for the most part, it's costs of detection and it's costs of internal failure. Okay? And what has proven true over and over again, both in studies that I've done with clients and in studies that a lot of other people have done in the software business, is that if you look at the cost of detection and the cost of internal failure together on a defect by defect basis, those costs are so much lower than the cost of external failure that the return on the testing investment is always positive. I have never seen it not be positive. Okay? So when people talk about testing costing money, that's actually incorrect. Testing saves money. How much money does it save? It varies. I've seen it range quite a bit. At the low end, the lowest return on investment I ever saw was 150%. So every dollar spent on testing had a net savings of $1.50. And I do mean net. It takes into account that dollar cost. So the net savings of $1.50. That's the lowest I've ever seen. The highest that I've ever measured was a 3,200% return on investment, where every dollar spent on testing saved the client, in this case a bank, $32 in the long run. Mostly that has to do with variations in the cost of external failure. Okay. Now I'm going to walk you through a brief example here in a moment, how to use a spreadsheet to measure cost of quality and calculate the return on the testing investment. The spreadsheet and an article that describes the use of the spreadsheet in this particular case study, as well as a full-length 45 to 60-minute video describing cost of quality in a lot more detail, can all be found at the blog entry that you see here on the screen. So, pretty intuitive name for the blog entry, right? Free tool for calculating software testing ROI. So, pretty easy to remember. But if you forget, I may send that out to the entire audience here via the webinar interface, and I can send it out to you guys here in the live audience as well. So let's take a look at this example. This is from an actual project, so these are not made up numbers. This is the actual return on investment that we got on one of our testing projects that we ran for a client. So we had an overall test budget for an initial release of this product, which was a hardware software product, of $1 million. Okay. Of that $1 million, $100,000 was invested in assets that would provide future value, things like test environments and the creation of automated tools and so forth. So I'm gonna remove those from the calculation of the return on investment here. Now, you know, from a pure accounting point of view, you're supposed to try to amortize this stuff over multiple releases and so forth, but this gets ugly if you do that, so I'm just going to pull it out. If you were to do it, it wouldn't change the calculations that much. So we take out the 100,000, that leaves 900,000 behind, right? Now, of that 900,000, $500,000 of the budget was expended on retest costs. By retest costs, I mean testing releases after the first release that would have been unnecessary if we'd been delivered a perfect piece of software on the first release. Okay, so this is all costs associated with testing the software over and over and over again until it's ready for release. So if we take that $500,000 out, what's left behind is $400,000. And those are costs of detection. That's money that you would have to spend regardless of whether you found any bugs. Setting up test environments, defining the tests, setting up bug tracking processes, those sort of things. Costs of detection, okay? We found 1,500 must-fix bugs during that test period. I know they're must-fix because that's what the sales and marketing people said. Got to fix those, and they got fixed, okay? So if we calculate the cost of detection per must-fix bug, that's $267 per bug. So that's how much it costs to just get set up and be ready to find those bugs and to run the tests the first time. Now, how about the internal failure costs? Well, all of those retest costs, the $500,000 in retest costs, are part of internal failure. Plus, based on the amount of developer effort that was expended on fixing bugs and the typical salary for a developer, annual salary for a developer at that point in time, I was able to calculate the test bug fix costs at $750,000. Okay. So the net internal failure costs is the total of $750,000 and $500,000. That's $1.25 million. And again, to look at it normalized per bug, if we divide by the 1,500 must-fix bugs that were found, our internal failure cost per bug is $833. Okay, 833 plus 267 is 1,100. So to find a bug and fix a bug prior to release, on average, cost $1,100. Y'all with me so far? Pretty straightforward math, right? Elementary school math, no partial differential equations here or anything like that, no degree in accounting required. This is basic spreadsheet stuff. So $1,100 per bug, was that a bargain? It was quite a bargain. So if we look over on the other side, we see that in the first 6 months after release, the company incurred $3 million in sustaining costs. Look, their costs of sustaining the product. I'm only counting the first 6 months because they were adding new features during that time, and I'm saying that after 6 months had gone by, the product had changed enough that you really wouldn't be fair to count the testing of the original release as providing a direct benefit against that. I think by doing this, I'm actually undercounting the return on investment. I think it's always good when you're trying to calculate return on investment to be conservative and to undercount it so that if somebody challenges your calculation and the numbers get changed, your ROI goes up rather than down. So $3 million in sustaining costs, of which, according to conversations with the developers and managers who were involved in sustaining, 50% of those costs were bug related. So we can say that the net external failure costs were $1.5 million, half of the $3 million. That makes sense? Yeah. There were 500 must-fix bugs found after the release in that first 6-month period. Okay, so that means that 1.5 million divided by 500, the average external failure cost per bug was $3,000. Okay, now let's calculate the return on investment. I said we found 1,500 bugs prior to release. 3,000 minus 1,100 is 1,900, right? Because basically every bug found and fixed prior to release saved $1,900 because the alternative was fixing that bug for $3,000 later, right? So 1,500 times 1,900 is 2.85 million. And notice that this is a net benefit because I have subtracted out the costs of detection and the cost of internal failure associated with each bug, right? So I'm not like double counting the testing here, that I have taken that cost of doing the testing out of the benefit. So it is a net benefit, okay? Now, if we want to calculate a return on investment, if we look at the net detection costs of $400,000, we take the net benefit of testing divided by the net detection cost, that gives us 700%. Okay, that's the typical formula for return on investment. It's the net benefit of the investment divided by the cost of the investment. The $400,000 is what we had to spend in order to capture that value, right? Now, some people would object and say, well, really, your investment in testing is not $400,000, it's $1 million. You should use the entire budget for that. I would say that's not actually fair because that cost counts the internal failure costs against the testing and effectively penalizes the test team's ROI based on the number of defects that were delivered. But even if we do that, even if we say, okay, fine, we'll use $1 million as the cost of the investment here rather than 400,000, our test ROI is still 285%. Which ain't too shabby. You're not getting that in the stock market these days. Yeah. Okay, so that's the technique. As you can see, very simple, fits on one page, can be explained to management, other stakeholders in the space of 10 minutes or less, and doesn't involve any sort of fancy mathematics whatsoever. All right, so any questions? I'll take questions via the Q&A interface on GoToWebinar or from the anonymous live audience here at the undisclosed mysterious location. Any questions? To the numbers? This one? Sure.
How do you calculate in the sustaining costs? Like how do you track percentage of bug related?
Okay, that's a great question. For those of you in the listening over the air here, the question was how did I calculate that percentage bug related sustaining costs. They're the 50% that you see in the upper right of the spreadsheet. The way that I did this in this particular situation is to actually have conversations with various managers who were involved in the sustaining effort and some of the senior lead individual contributors, and ask them, well, what do you think? How much of your time is spent working on new features as opposed to dealing with bug fixes? And the pretty consistently, the number that I heard was about 50%. If I'd heard wildly different numbers from everybody I talked to, I'd be less confident in this. But I heard pretty much the same number from the half a dozen people that I talked to. Would it be better to do a more precise study of that? Yeah, probably so. And in organizations that use what's called chargeback to bill hours against specific types of activities, it is possible to do that kind of calculation. But in this organization, everybody was a salaried employee and there was no chargeback or anything because everybody was working on the same product. So we really couldn't get any more precise than that.
Your cost will only go up because now you're taking account the report from the field, triage from NOC.
Yeah. Yeah, the cost, if anything, this is the net external failure cost of 1.5 million is very conservative because it doesn't take into account, as you said, like the network operating center costs. There was a whole procurement group, or not procurement group, but the distribution of some kind or another. The people that actually push the updates out to the devices, and I didn't take that into account at all of how much it costs to do those update pushes, and a lot of that was triggered by bug fixes. So if anything, this number is low. Which again, I think is a good way to do this. If you're going to do this analysis, you want to keep it simple. You want to be conservative. You don't want to set up a situation where you've got somebody who's got an accounting degree who's in there taking you apart over your numbers because you got way out on a limb. And you really don't have to, because as I said, what I've seen with these studies over and over again is the ROI number is so big that if somebody wants to quibble about it, it's like, okay, so say it's half, say it's only 350%, right? Say it's only 140% or only 150%. You getting that in the stock market, right? Where are you going to get that kind of return, right? It's a phenomenal return. So I got a question here from online from Sheikh, who asks, what is the billing rate of a tester that you have assumed in these calculations? You actually do not have to have a billing rate. This was done using figures based on the salaries at the time in that particular location, but the same exact analysis can be done without salary information at all, just using person hours. Because if the number that you're after is the percentage return on investment, that pretty much comes down to, it's a percent. And if you use person hours, you can do the same kind of calculation. Okay. And it is effort driven here. I'm not, there's no sort of, attempt to capitalize equipment or any of that kind of stuff. Because again, that just gets really hairy. It gets you off into all of this accounting stuff where I don't have an accounting degree. I took 2 accounting classes total in my entire college career. And, I'm not an accountant. I don't play one on TV, and I'm not going to get into trying to do silly accounting tricks. Let's see. I've got some other questions here from Joella. Joella asks, this model assumes all users get the new release at the same time. Is there a way to calculate when users can run on older builds and request a new one on their schedule? Actually, Joella, this does not assume that the users get the new release. This is purely looking at the effort on the sustaining side, the maintenance work that's being done. It does not take into account the costs to the user of installing these, which again, if anything, would drive the net sustaining cost and the estimated failure cost per bug up, right? I'm not taking that into account. So in an organization where you are dealing with users who are basically paying the price in terms of productivity, time spent, and so forth on maintenance releases, then that you can include that in the sustaining cost, which would then increase the ROI. You have to decide whether you think that's actually worth doing, because it could, spark some contentious conversation that distracts people from your main point, which is that testing is a great bargain. Let's see, I have a question here from Kathy, who asks, can you go over again where the 2.85 million figure came from? That's this figure here, the net benefit of testing in the bottom left. That is 1,500 times 1,900. It's so there were 1,500 must-fix bugs found during testing. Each of those must-fix bugs, when fixed, saved the company $1,900, because that's the 1,100. The 3,000 minus 1,100, that's the savings of the associated with each bug. And so that's where the 2.85 million came from. Yes?
How can you calculate sustaining costs for something that's unreleased?
I was just looking at a question online from Rushba that asked the same thing. How can we prepare cost of quality for an ongoing project where we don't know the sustaining costs up front? So, yeah, that's going to be a little bit more challenging. You would estimate it. You would have to, of course, admit that it is an estimate. But the way that you could do it is if you look at historically what your costs of external failure are compared to your measured costs of detection and internal failure for your testing. And then you look historically at what your defect detection effectiveness is, which we've been talking about here. So if you say that, yeah, on average, we find 90% of the bugs. So here's how many bugs we found now. So the additional 10% is this. Then you could estimate what your number of released bugs is going to be. And then that would allow you to come up with some estimates for what the sustaining costs would be. Here again, I think it would be very wise to be conservative in your estimation, so that after the project, when you actually measure your ROI, you get a bigger number, not a smaller number than the one that you put forward, right? Let's see, I've got a question from Donald here. Is opportunity cost a factor to consider when development is spent fixing a bug and not producing new code? That's a great point, and it is not something that this model takes into account. That's certainly worth mentioning, that opportunity cost is it's lost productivity, right? So, there's the cool new feature that didn't get written because we were so busy fixing bugs, right? Hard to measure what that opportunity cost is, and I think you can get out again on the thin edge of a branch trying to measure that kind of stuff, but it's certainly worth bringing up just as qualitative note as you're going through this. Let's see, I got a question from Jonathan here, who says, are the costs per bug, internal and external, indicative that only the must-fix bugs were fixed, leaving the non-critical issues of the software? Has the cost per bug been a little inflated by including the cost to fix non-critical bugs? The way that I'm saying that bugs were must-fix is if they got fixed. If they weren't must-fix, then they got deferred, and so those are not fixed. And I'm not trying to account for issues of cost of carrying the technical debt effectively. I'm not trying to get into this question of, was a bug that was deferred in development subsequently determined to be must fix in production, in the sustaining situation, because then there'd be the risk of potentially double counting it. So basically, I'm just saying, if a bug was fixed, if it was decided to fix the bug, it was a must fix bug. That was a decision made outside of testing, and that's how I'm counting it. Again, I want to be careful about not double counting. Kathy asks, were the external failure costs for must-fix release bugs, including bugs from new features or only bugs found on the original code put in the product? Kathy, it would not have been possible to distinguish that very distinctly. So the way that I controlled for that was by only measuring sustaining costs over the first 6 months. And what I assumed was after 6 months, there'd be enough new features that had been added as part of the monthly releases that it would have been very difficult to say what percentage of the bugs were associated with the new features versus the old features. So I just left it out after 6 months. If I'd included that, the ROI would have gone up, but it would have been much more complicated, and I would have had to explain the calculations to people, and it just gets you into a morass that distracts from the main point which you're trying to make, which is that testing saves a ton of money. Okay, any other questions from the audience? Yeah.
This whole method is mainly used as a way to convince people that testing saves money. What we've talked about so far, a lot of the challenges are like specifics about, like how much exactly money there is that it saves. And for the most part, the response has been like it's doesn't matter because it's still going to be huge. Are there any other ways that you've seen this challenge in your discussions with developers and most people? Like, what are the main challenges that you get? What you want to say?
Usually I get questions, clarifying questions, and as long as I'm careful to be conservative, I don't get a whole lot of challenges beyond the, well, why are you using 400,000 rather than $1 million kind of thing of, what's the correct basis for the, how much was invested in testing. Now, in some situations, and this may be one of them, the argument of saving a lot of effort might not be the top thing on people's minds, right? Which is something that we've discussed before. There are also qualitative benefits associated with testing, which we discussed in the Advanced Test Manager course that are important to emphasize. So you kind of have to gauge your audience. This is an argument primarily based on efficiency, right? It's more efficient to find bugs and remove them prior to release, right? You could also extend this to say, not only is it more efficient to find bugs and fix them prior to release, it's more efficient to find them earlier in the process. So this can be this cost of quality technique, by looking at the costs of defects earlier in the life cycle, can be extended as a shift left argument of, let's try to drive defect detection earlier in the process, because what you tend to see is it may be $1,100 in system testing to find and remove a bug on average. It might be as low as $50 when you're in design reviews and requirements reviews and prototype reviews, right? So the argument can be tweaked that way to make that point, but it is primarily an argument from the perspective of efficiency, and so it's going to be most effective against in the case of somebody whose main concern is about efficiency or related things. Did that answer the question?
Yeah.
Okay, cool. All right, great. Well, we try to keep these things short. We've been 30 minutes, so I'm going to go ahead and wind it up. Thanks to everybody here at our mysterious, undisclosed location. Thank you. And for those of you online, thanks for your participation.